Dear students, under the topic ordinary differential equations, we are going to learn the method of variation of parameters. Using this method, we are going to solve a second order ordinary differential equation which is of the form d square y by dx square plus a1 dy by dx plus a2 y is equal to capital X, where capital X is a function of small x. Now this can be rewritten as y double dash plus a1 y dash plus a2 y is equal to capital X, as we all know that y dash represents dy by dx and y double dash represents d squared y by dx square. The steps involved in solving the problem is given here. So after writing it in the standard form, we have to find the auxiliary equation of the ordinary differential equation, and then we have to find the respective roots. This is the normal step which we usually do for all the problems. And after that we have to find the complementary function which is given by, and the complementary function has to be compared with af1 plus bf2. So after obtaining the complementary function, we have to compare it with this and we have to obtain the values of f1 and f2. And after finding the values of f1 and f2, we have to differentiate them in order to find f1 dash and f2 dash, so that we can find the Wronskian W, which is equal to f1 f2 dash minus f2 f1 dash. You will understand these steps better by solving the problem. But anyway, I'll just complete the steps which has been involved in solving the problem, and this W is known as Wronskian. So Wronskian of two functions f1 and f2. And if we are finding this W in order to find the value of capital P and capital Q, which is given by these integrals. So f2 divided by W multiplied with capital X dx, which is integrated and multiplied with a negative sign, gives the value of P. In a similar way, Q is equal to integral of f1 by W capital X dx. So after finding these two, we have to find the particular integral by substituting it over here. The particular integral is equal to Pf1 plus Qf2. We have to substitute the values of P and Q over here, and finally by adding the complementary function and the particular integral, we get the general solution. Now we shall solve a problem in order to understand these steps. So here we have problem 1 under this topic. So let us solve this equation d square y by dx square plus y equal to secant x using the method of variation of parameters. So what is the first step? Let us write this given equation in the standard form. That is, we have to write it in this way. So we will rewrite this equation. We know that d square y by dx square can be written as y double dash plus y is equal to secant x. Now here, when we compare with the standard equation, we see that right side is x. So we have to take the function secant x as capital X. So capital X is equal to secant x. So x is a function of small x. So after making this, after finding capital X, what is the next step? The second step is we have to write the auxiliary equation and find the roots of the auxiliary equation. So what is the auxiliary equation of the given question? Now here we have y double dash plus y is equal to secant x. So the auxiliary equation will be, for y double dash we have, so the auxiliary equation is given by, for y double dash it is m square plus the constant 1 is equal to 0. So after writing the auxiliary equation, we have to find the roots. That is, we have to find the values of m. So from this, m square will be equal to negative 1. And so from this, m will be equal to plus or minus square root of negative 1. But what is square root of negative 1? It is I. So therefore, the values of m is equal to plus or minus I. So we have obtained imaginary roots. So alpha plus or minus I beta is the imaginary root, and so the value of alpha is 0 and the value of beta is equal to 1. So we have got the values of alpha and beta. We shall now substitute these values in the complementary function. So whenever we obtain imaginary roots, the complementary function is given by. So this is the complementary function for imaginary roots. Now here at the place of alpha, when we substitute 0, we will have e power 0, and we know that the value of e power 0 is 1. And so this will be equal to, so this value will become 1, and so we will have a cos, and what is the value of beta? Beta is equal to 1. So beta x, so 1x, so it will be cos x, plus capital B sine beta x. The value of beta is 1, so it will be only x. So therefore we have obtained the complementary function. Now we shall compare this complementary function from the procedure of the problem, that is step 3. So what is step 3? Find the complementary function CF, which is equal to AF1 plus BF2. So we have to compare with this. So here the complementary function is A cos x plus B sin x, and we have to compare it with complementary function which is equal to AF1 plus BF2. Now when we compare, we see that the value of f1 is what? Cos x. The value of f2 is sin x. So after comparing, we find that the value of f1 is equal to cos x, and then the value of f2 is equal to sin x. So what is the next step? So as per the procedure, after finding the complementary function, the step 4 is we have to find f1 dash and f2 dash. That is, we have to differentiate f1 and f2 with respect to x. So f1 dash will be the differentiation of f1. So what is the differentiation of cos x? It is minus sin x. In a similar manner, we have to differentiate f2, which is f2 dash is equal to the differentiation of sin x is cos x. So after this, next we move on to step 5. That is, we have to find the value of w, which is known as Wronskian. So the value of w is given by f1 f2 dash minus f2 f1 dash. So let us find this value. So when we substitute the values of f1 f2 dash over here, w will be equal to what is f1? f1 is cos x multiplied with what is f2 dash? f2 dash is cos x. So cos x is multiplied with cos x minus what is f2? f2 is sin x, and it has to be multiplied with f1 dash. f1 dash is minus sin x. And so on simplifying this, what is cos x into cos x? It is cos squared x, and minus into minus will become plus, sin into sin, that is sin x into sin x is sin squared x. And what is cos squared x plus sin squared x? By the trigonometry identity, we know that it is equal to 1, and therefore we have obtained the value of w is equal to 1. Now after finding the value of w, in the next step we have to find the value of capital P and capital Q, that is step 6, to find the value of capital P and capital Q by using these two formulas. So let us first write these two formulas in our problem. First we shall find P, for which the value of P is equal to minus integral f2 by w capital X dx. So we shall substitute one by one in this. So P will be equal to minus integral, what is f2? From our problem we see that f2 is equal to sin x. So let us substitute that. So it is sin x. And what is w? W is equal to 1. So divided by 1. So anyway, it is going to remain the same. Multiplied with capital X. What is capital X from our question? It is equal to secant x. So in the beginning of the problem, we wrote capital X. So that we have to substitute. So it will be secant x dx. Now furtherly we shall simplify this. So this will be equal to negative integral. So sin x by 1 can be written as sin x itself, and secant x can be written as 1 by cos x dx. And so this is equal to minus integral sin x by cos x dx. But what is sin x by cos x? It is tan x. So that's equal to minus integral tan x dx. By the formula of integration, integral tan x dx is log of secant x. And so this will be equal to, we have this minus sign, so let me write that. So minus, log of and secant x. So therefore we have obtained the value of P to be equal to minus log of secant x. So we can write it. Now next we shall find the value of Q. The value of q is given by q is equal to integral f1 divided by w capital X dx. So when we substitute each of the values over here, integral, what is f1? So from our problem, f1 is equal to cos x. So we shall substitute that. So cos x, w is equal to 1. And what is capital X? Capital X is equal to secant x. So secant x dx. So if you see, we know that secant x is 1 by cos x, and so this will be equal to integral cos x multiplied with 1 by cos x dx. And cos x will get cancelled, and we will be having integral dx, which is equal to x. So therefore the value of q we have obtained to be equal to x. We have obtained the value of p, and we have also obtained the value of q. So what is the next step? So from the procedure, after finding the value of p and q, we have to find the particular integral, which is given by capital P multiplied with f1 plus capital Q multiplied with f2. So let us write this. So we have written that, and so that is equal to, what is capital P? It is here, minus log of secant x, and this has to be multiplied with f1. What is f1 in our problem? F1 is cos x, f2 is sin x. So we shall substitute that. So multiplied with cos x, and then plus capital Q. Capital Q is x, and f2 is sin x. So x multiplied with sin x. So we have obtained the particular integral as minus log of secant x cos x plus x sin x. That is, I will write it clearly here. I will write this cos term in the front. So minus cos x log of secant x plus x sin x. So this is our particular integral. Now we have to write the general solution. The general solution is given by, so the general solution is equal to complementary function plus the particular integral. So therefore it will be equal to, that is, the general solution will be y is equal to complementary function plus particular integral. So y will be equal to, what is complementary function in our problem? It is here. The complementary function is a cos x plus b sin x. So we will substitute this. So a cos x plus b sin x plus the particular integral. So particular integral just now we have found here. So we shall substitute it. So I will write this first. So plus x sin x, and then this minus cos x log of secant x. Now if you see, from these two terms we can take cos x in common. So we will be obtaining y to be equal to, so within the bracket we will have here a, and here we will have minus log of secant x, because we are taking this cos x and this cos x is in common. So cos x plus, now in these two terms we can take sin x as common. So we will be having b plus this x multiplied with the common sin x. So therefore this is the solution that we have obtained by using the method of variation of parameters. In our next video, we will solve another significant problem under the same topic. So kindly follow the next video lecture. Thank you.